Hey, thanks for clicking on this video. If you want to follow along, the links to the companion worksheet are in the description below. So today we're working with writing summation notation. So we're going to be given series, and we want to write what this would look like using sigma. So here we have 1, 4, 9, 16, 25. And so what's happening is we're plugging in a number, and then a bigger number, and then the next bigger, and the next bigger, and the next bigger, and then we're doing something to it. And usually, with most series, you start plugging in with 1, then with 2, then 3, then 4, and then 5. So what's the relationship here? Well, we're taking this number on top, and then we are squaring it. So that is the formula, n squared. Now, what's the first number we start with? 1. So on the bottom of our sigma, we're going to put n equals 1. And what is the last number? That is 5. So that is what this series looks like. So number 2, here we want to express this sum. Now we're starting with 1, and we're going all the way up to n. Now that's important to notice because we can't use n in our formula because n is the last number. So we have to use some other letter. So I'll just use k. K equals 1. And so what are we doing with 1, 2, 3 all the way up to n? Well, we're taking the square root. So that means the square root of k. Number 3. Here we have 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. Well, the numbers aren't changing. So what are we doing? We're plugging in 1, 2, 3, 4, 5, 6, 7. But since the numbers don't change, our formula is very simple. It's just 3. And so our variable, whatever it is, because it doesn't show up, is from 1 up to 7. That's the last number we plugged in. And so this one is very, very similar to that one of those first examples we did on the evaluating summation notation, where no matter what the variable is, you're just going to get that same number because there is no letter there. Number 4, here we've got 1, 2, 3, ... all the way up to n. So again, we can't use n. Got to use a different letter. And so what are we doing? Well, we have a fraction. So on top, the numerator is just whatever number you're plugging in. So that's k. But on the bottom, this number, 2, 3, 4, is 1 more than that. So that's going to be k plus 1. And you notice that this formula matches this one. The only difference is that this is what you get when you plug n in for k, for that last term. Okay. Number 5, here we want to express this sum. And so we're going 1, 2, 3, all the way up to 30. So we have n equals 1 as our first number, 30, but we're not doing anything to it. So that means the only formula is just n. Whatever that number is, that's what's getting plugged in, and that's what you're adding. Number 6, here we want to express this sum using summation notation. So here we have 4 plus 6 plus 8 ... all the way up to 60. So here I know this is 1, this is 2, this is 3, but what number is this? I'm not quite sure. We're going to figure that out. Now if you notice, to go from 4 to 6 and then from 6 to 8, we're adding the same thing. We're adding 2. And so that makes this an arithmetic series. So that is our common difference. So what we want to do is over here we want to write what is the formula for the nth term. And so that's going to be, we start with the first term, and then we add the common difference to n minus 1 number of times. And that's what we do anytime we have an arithmetic sequence. We just put in the formula for the nth term. But how do we figure out what this is? Which term that is? Well, we set that equal to the formula for the nth term. So 60 equals 4 plus 2 times n minus 1. So now if we subtract 4, we have 56 equals 2 times n minus 1. So if I divide by 2, 56 divided by 2 is 28 equals n minus 1. And then if I add 1, we get 29 equals n. So that is the number of this term. We plugged in 29. So that means 29 is what goes up there. Number 7. 7 plus 9 dot 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 all the way up to 101. So this is very, very similar to this one. We start with 1. Now the last term, we don't know. But we write over here the nth term. So from 7 to 9, we are adding 2, n minus 1 number of times. And since we aren't given a third term, we just have to assume it's arithmetic without any other contravening evidence. So we set 101 and 7 plus 2 times n minus 1 equal to each other. And then we're going to solve for n. So I subtract 7, and so we get 94 equals 2 times n minus 1. And then we take 94 and divide by 2, and we get 47 equals n minus 1. If we add 1, we get 48 equals n. And so that's the number that goes up top. Now here with number 8, we have 1/3, 1, 3, 9, 27, 81, 243. So if I start with 1 here, we're going to go out 7 terms. So n equals 1 to 7. And what is the nth term? Well, from term to term, we are multiplying by 3. And so that is a common ratio. This is a geometric series. So the formula is you take the first term times the common ratio, n minus 1 number of times. So that is what this summation notation will look like. Again, as I said in the previous, with evaluating summation notation, whatever's carrying the exponent, that is the common ratio. Number 9, same thing, 1, 2, 3, 4, 5, 6. Now from term to term, from 8 to negative 16, from negative 16 to 32, we are multiplying by negative 2. So we start with n equals 1, and we end with 6. And our first term is 8 times negative 2 to the n minus 1. So there is our formula. And then finally, number 10, here we have 0.4, 0.04, 0.004, 0.004, but it's got a dot, dot, dot. And what that means is that it's going to have an infinity on the top of it because this series will never end. Now, how do we write the nth term? Well, as we look at this, here we're multiplying by 0.1. And so that is our common ratio. So we take the first term, 0.4, times 0.1 to the n minus 1. Thanks for watching. If you like this video, hit the like button, and if you want to see more, click the subscribe button. To support this channel, click the links in the description below. Thanks for watching, and remember, the best way to understand something is to do it.